Okay. So the last session of the day is called Planning US HEP, Past, Present, and Future. And our first speaker is Steve Ritz from University of California at Santa Cruz. And he'll tell you who he is, and we'll go from there.
Okay, good. And I can take this thing off, right? Okay, very good. These are personal perspectives. I'm not representing anybody, which is kind of nice. I was a co-chair or co-coordinator of the Cosmic Frontier with Jonathan Fung. Is Jonathan here? For the last snowmass. So I certainly remember what I felt like at this time after all of the work. So I appreciate all of the work everyone here is doing. And I was also the chair of the most recent P5. So these are just some personal, some suggestions for things to consider. Let's see, is this work? Oh, it's working. Great, good. All right, so can we move this thing a little bit? No, yes. Let's see if that works. So just two caveats up front. This is a talk about the connections between snowmass and P5 the last time. And I think it's obviously true to everybody, but snowmass is about much more than that. Snowmass isn't just about feeding things to P5, but there is a component of this that is quite important. So it's that component that I'll be talking about. The other thing is when you look historically, everything seems a lot neater and easier and sure. And that just isn't true. And it is therefore good to, why doesn't this work? To listen to historians. I'm really fond of this quote, which is that it's very difficult to remember that events now in the past were once far in the future. All of the uncertainty people are feeling right now, this is the way things felt in the past, maybe even worse. So that's okay. It's not like people understood how everything was going to pull together beforehand. We've heard this over and over again. The previous snowmass was essential to P5. And really, I'd like to talk about why from my perspective. You already heard from Andy, the statement in our report that a vast number of scientific opportunities were investigated, discussed, and summarized in the snowmass reports. But the other thing is that with all those documents and all the effort that went into them, it really paid off because it enabled P5 to write a short report. And if you've ever had to do one of these things, you know, writing a short paper or a short report's a lot harder than writing a long one. And by being able to have all of these documents that were hierarchically arranged, if anyone was interested in something, they could drill down and follow to get the information. I had staffers call me and thank us for writing a report that was possible for them to get through in an efficient way that spoke to them, that they could understand, and then they could know that they could find out more information toward the back of the report and then also with the snowmass documents. So that all the work that's being done writing is also really, really important. And here's the report. You've heard a lot about the P5 report. If you haven't read it and you have an opinion about it, please do read the report. Andy said that, mentioned that we had these 11 questions. It was really useful to get these questions. I remember when somebody, I think it might have been Michael Peskin, maybe it was John Ross, I can't remember who it was, said we really ought to produce these questions. And they're great questions, and I encourage you to read through them. It's more than 30 questions though, and that was going to be hard to write an executable plan to in a way that people from outside our field were going to understand. And so we did distill these down into the 5 science drivers. You've heard them many times before. One of the things about hearing something many times is you stop paying attention to it. And in fact, if you step back and look at these questions and the drivers, there's a fantastic field asking really interesting questions that have, you know, good opportunities to answer these really exciting questions. And again, we didn't prioritize the drivers deliberately because they're all intertwined, probably in a way that was more deeply connected than we actually understand now, and certainly understood then. But the projects had to be prioritized due to just finite resources. So we distilled the questions down into the drivers for the purposes of explaining what we wanted to do. And in principle, that could be done by SNOMAS this time. There was a question this morning on the Google Doc, can the science drivers be modified? I don't see why not. If they don't work or if the field has moved, then that certainly is a possibility. If they're working, great. And if not, then that's something that SNOMAS could consider doing, certainly, I think. The other thing real quick, looking back is, you know, if you look at all the output, it seems like everything was orderly, but it was not that orderly. It was messy, and messy is good at SNOMAS. It's a good thing. It means the field is vibrant. This was a summary slide I made for, you know, an interim cosmic frontier discussion. And, you know, it's okay. In the end, we have to come together and explain. So what else was essential from SNOMAS, from my perspective, that fed into P5? Well, first of all, providing a summary of what has changed since the last SNOMAS would be very helpful, I suspect. You'll have to ask the new P5. As before, I would expect P5 will need to articulate what's happened since the previous report, because that's going to frame the new directions or the recommendations. And just for reference, this is what was going on last time. If you look, you know, there was a lot of physics going on. The Higgs had been discovered since the last 2008 P5 report. There were Nobels related to different areas of the field. Again, the intertwined nature of the science drivers. Sine squared 2 theta 1 3 was measured, and that helped to point to next steps. There were also big programmatic changes. Trigger warning, DUSEL didn't continue, and so that was really hard, I know, for some of you in the audience. The Tevatron ceased operations, PEP2, the B factory stopped, and inflation adjusted, and that meant economic inflation, not cosmology. The funding continued to decline. The other thing really important is that last P5 was by design a very outward-facing panel. There were people from a large number of members from other countries and other regions. They were wonderfully helpful. It was very, very important. And in fact, you'll notice the P5 report subtitle was Strategic Plan for US Particle Physics in the Global Context. And the global nature of the field was something that I think we helped to explain, and that's a really good thing. And I'm certainly hopeful that the international colleagues we have here are feeling completely welcome and part of the process as well. And there have been significant changes in the international context. You can each make your own list, I'm sure, since 2014, and that's important. All right. Diversity, equity, inclusion, and climate. And by climate, I do not mean the planetary weather aspects, but what's it like to be in our community? What's the climate for all the different members of the community? That's a really, really important focus. Diversity, equity, inclusion are words that are getting too easy to say without thinking about what they actually mean and underlying systemic effects that we just are affected by. And I would say that we're not going to fix this. We've done the experiment. We're not going to fix it just by each of us trying to be unbiased. It's been known for a very long time that if overall societal pressures and systems are biased against some people, then if you have interactions with that part of our community, and if every one of your interactions is perfect, that's still not going to fix the problem, okay? And these things, I think, need to be addressed, and we have a lot of work to do. Most of you know about the the STEM strike for Black Lives that happened a couple of years ago. It was extremely important. If you haven't looked at this website, which I think most of you have, I strongly recommend it. It really is great. I would say that yes, this is an important part of the snowmass process and could be part of every frontier message. How is each frontier doing and how will it do better? I don't think this is something that should be left just to, the group FCOM F3 or, I think it's great that that group of people has come together to do this. It's really important, but I think it should be intertwined again with all of the frontiers, I would suggest. Why? Well, because we have problems to fix, and also because it will attract the best people into particle physics. Okay, if our culture continues to improve, then young people, the brightest minds, are going to want to come and work with us. And if not, then they won't. And so again, early career voices, we already heard. Thank you very much for that talk earlier today about Snowmass early career. Snowmass Young last time was incredibly important. We relied on them and their persisting organization to connect with P5 and our town halls and so on. So that was great. I just mentioned, since we saw the pie chart this morning, there was another pie chart here, which I really give the organizers kudos for posting, which is the self-reported gender distribution of the people who signed up for Snowmass. And I think each of us has maybe 2 or 3 or 4 reactions all at the same time when we look at this. Some ways things are better, in some ways they are not. And so that I would just say is evidence that we have a lot of work to do. But kudos for doing that, and doing it in this way, I think was a good thing. All right. The importance of program balance. So I would say that I have trouble with the F word, frontier, and also flagship, but a subfield or frontier or a working group isn't defined by one large project. And this isn't original to me, but a facility isn't a vision. So what are the questions that can be answered, and how can they best be addressed with a mix of small, medium, and large experiments? That's a key thing, I think, for frontier messages that give really good input to P5. How should P5 think about the opportunities in your subfield? Okay. I would just remind you that the last P5 made a portfolio of smaller experiments as a higher priority. The idea being that we had budget scenarios meeting a top line number we couldn't go above. And so what we did was say, okay, there's this this amount of money that we're going to make sure is set aside off the top, okay? And that should be used for smaller experiments. And we gave reasons why that's important. I don't have time to go into here, but there are a lot of good reasons for it. And I think that we at Snowmass can help P5 make a similar case for why a broad distribution of projects is important, and then give existence proof examples for smaller projects. That's great. I don't think it's plausible for a group like P5 to prioritize individual smaller projects and converge in a reasonable amount of time. But it can do something like this again to help make sure the budget's supported. And again, the international contexts are critical. This goes without saying, but I think I'll say it anyway, which is the importance of theory. It's true that theory is necessary for the success of projects. You cannot have a successful project at every stage of an experimental project. Theory plays absolutely essential roles. It's part of the ecosystem. You take it away and the ecosystem dies. Gives meaning to the data. I don't mean to quote the Big Lebowski, but it really ties the field together. It points in new directions. And when you're making choices about capabilities, particularly even if you're mid-project and you have to make some changes, theory is incredibly important. But in addition, of course, it's an essential focus in its own right. It reveals the important questions and issues, and it provides the intellectual underpinning and new ways of thinking. So it would help if experimental focused areas also talk about the importance of theory. Before unity, which is really important, by the way, when we all come out of this, before unity, there needs to be vigorous discussion. You can't have really honest unity if you don't first work it out. So ideally, this is a process in which ideas are discussed, debated, and refined by everyone together. And we shouldn't hesitate to ask the tough questions, but it should be done in good faith. It should be an honest trying to understand each other. And that we all should understand that tough questions from other frontier areas are gold because they help us to develop viable options, really viable options that can realistically work. And by looking skeptically at our own subfields messages and others, we can strengthen them all together. And then the debate at Snowmass is really important for P5 to hear because P5 has to make hard choices because not everything can be done. And the reasons for those choices have to be articulated. And that can only happen with the input for the various aspects of the debate. And I will just say here, something from our report, which is that no topic, the last time around anyway, no topic or option was off the table. And that was true, I believe. All right, the opportunity of crossroads. Again, the intertwined nature of our field is great. It is an opportunity for us beyond trying to give input to P5 to broaden our own research and to make connections. But it's also true that we can't expect others to become interested in our own subfield if we're not interested in theirs. And breakthroughs can really happen at Snowmass, and it's happened lots of times before. The liaisons are great, but the question is, will the frontier messages actually connect to each other? That would really help P5, and I'm sure, and I've given some examples here. The connections, for example, between the neutrino frontier and cosmic energy instrumentation accelerator, R&D, for example. And this point was already made that neutrinos themselves don't care whether people call it nuclear physics or particle physics. And the last P5 report also tried to link arms with science research generally, because it's really important for decision makers in Washington to hear about the importance of science. All right, perfect. When it's all over, the others, because I was asked what kind of makes this all work or how have we been effective, I wanted to add something, which is after this is all over, it is important to work together for the whole program in a unified manner. So every year we get together and write and update this 2-pager, which is taken to visits to decision makers in Washington and elsewhere. And everyone sings from the same sheet of music. There are additional materials, more made every year. You can find them here to describe so many aspects of our field, but then talking about the progress and the priorities done in concert with the DPF and the users groups and lots of other people. We ask for ideas for what we should write in here. They are developed and they are there for everyone to see and use. And this idea of pushing the whole program is so powerful. Okay, if different people walk into the same office and each say a different part of the program is really the most important part, and what those other people do is just kind of boring, then the sum of all of those is nothing, right? There's no overlap. And so it's really important to work together. All right, so finally, positive, clear, and actionable messages. Again, Snowmass can provide clear questions, viable options. Nothing should be off the table. I want to suggest 2 ideas that might seem different, but I think you can hold them simultaneously in your own minds because you're all brilliant, to paraphrase Fitzgerald. Realism is important, and we certainly made tough choices, but big aspirations that are well motivated are also really important at the same time. And so we did write this in the P5 report that as work proceeds worldwide on long-term future generation accelerator concepts, the US should be counted among the potential host nations. And that at the same time as making hard choices, we felt the responsibility to aspire to an even bolder future. And we do not see those as contradictory responsibilities for a community or for a panel, because yes, every year's budget is a balance sheet, but we also have a great capacity to grow, and that's limited only by our collective imagination. All right, diversity, equity, inclusion are areas of necessary attention. I would use the word necessary, and different thinking, and cutting across frontiers is incredibly important as well as the evolving international context, which certainly has changed. And that's it. Thanks.
Okay, now remember that we're not asking questions of the speakers right away. We're waiting till the end of the session when all the speakers have spoken, and then we're going to call them up and recognize questions from this audience and also questions from remote users via a Google Doc that's been prepared for this meeting. So the next speaker is James Shank from the NSF. He's a program manager from NSF and known to all of us, or many of us, pardon me, for his long service in Atlas and his an Atlas software and computing expert.
Thank you, Joe. Yeah, good. Yeah. Okay. No. Okay, thanks. So this talk is on behalf of many other people at NSF who are not here right now, but will be here at various times during this week. Denise will be here next week. And Keith was going to be here, but has dropped out because of some health worries about COVID here. And I think that's true of Darren also, but William Wester will be here later in the week. Okay, so overview. I'm going to talk about what is the physics division at NSF, what's going to happen, what we expect to happen out of SNOMAS, the previous P5 again, and I will also mention the National Academy study and what we're hoping to get out of that. And then I'll talk a little bit about the near-term perspective, the near-term being before we get a report out of P5, for example, and other NSF initiatives that you've been hearing a lot about, AI and QIS. Okay, so here's the org chart of the division. And I just want to point out that we are a group that at least
Zoom is closed. Zoom is closed. Zoom is closed. So you connect to Zoom.
good, thank you.
There we go. Are we? Yeah, it's recording. Everything's fine. Yeah, let's redo the share. Share screen. This is the correct one.
That's the right one, yeah.
Yeah.
I think so.
Okay.
Yeah, can you hear me now? Is there caption on? I don't think it is. Should I continue or should you want to fix it? Okay, okay. All right, we're back in business. Okay, so I was going to point out that the physics division, at least before the COVID, we're all on the same floor of the same building. We were close by each other. We talked to each other every day. That's less so now, but we still try to do that. And we have these divisions, but they're not tightly siloed. So we have overlapping programs. There are things that are in the fore now, like this precision measurement program. This will be talked about and further in one of the NSF lunches, which I'll point out at the end of this talk. Okay, so in particular, again, the frontiers don't fit exactly into this division, and we don't force projects to be in any kind of frontier. Okay, so what's going on with NSF and various community-wide panels? So the snowmass study is going to be complete at the end of this meeting, we hope. And we certainly appreciate the community input and the science that needs to be done. This is all very important. The new P5, I think we're entering a new era. Steve mentioned the importance of theory. I think unlike the last P5, we're at a point in the science program where it's not so clear where we want to go. And so theory may be more important. Where do we look next? Okay, so we are anxiously awaiting the report in 2023. I do want to talk about the NASM study. I'll point out, I'll give a couple slides about that. Independent of P5 now, it's going to focus on the science that drives the field with no connection to any existing projects. So the particle physics project prioritization panel, that project prioritization doesn't fit well into the NSF way of doing things either. But we see from the last time that we did make it fit, and I'll talk about how that happened. Okay, but the NASM study will focus only on the science drivers and a few other points that I'll also point out here in the next couple slides. Mainly about thinking about new experimental approaches and reaching to form tighter connections to other disciplines. Okay, so the previous P5, of course, there's the famous two top priorities, one near-term, the highest priority near-term project and the highest priority in its time frame. So NSF, in reaction to this, formed an advisory committee, the MPS Math and Physical Sciences Advisory Committee, which is a subcommittee of that, which was often called the Young-Ki Kim Committee. She was the chair. So the number one priority of P5 back then strongly impacted existing and future investments in LHC. And we had, let me just skip to the next slide for a minute to show. So this is actually a pie chart of where the money goes, which experimental programs. Right now, this is for 2021, but a similar pie chart for 2014 looked very much the same, except the LHCb was a little bit smaller, maybe neutrinos was a little bit bigger. But you see one thing, a takeaway here, I don't want to go into the details, but the takeaway is that the LHC completely dominates the EPP program. Okay, and so this number one priority fit within the community that we were already funding. Okay. So, but why didn't we just immediately say, okay, we're just funding that? Well, there were lots of questions like, can we afford to do it in a meaningful way? So this MPS-AC subcommittee studied questions like, can we afford to do it and how do we do it? And their conclusion was we should push for a big project, which is a major research equipment project, MREFC. And this, I point out that this started in 2020. It was before it was officially underway. So there's 6 years there it took to push this. And it was a lot of hard work, and that was putting on a fast track. Normally an MREFC project takes even longer than that. So this should inform you what could happen after the next P5. Okay, so I already mentioned this slide. So let's go on to the National Academy study. So this just came out. I don't know if everyone has seen the membership here. You know, the National Academy picks these independently of us. So I mean, the DOE and NSF gave recommendations for who we thought might be good chairs, and I think they picked people that were compatible with that list. But the rest of the panel was made by them. Okay, so this is supposedly gives them the independence that we wouldn't get from a P5 panel, which is you know, often criticized as being people from this community advocating for stuff that they already like. So this gives a more independent look at the science drivers. Okay, so this committee had wasn't called a charge, we call a statement of task in NASM speak. And this statement of task had only 4 points, and these are them right here. And I want to take a minute to actually read them just so everyone knows what's going on here. So one is identify the fundamental questions in particle physics that could motivate research in the next decade and beyond, irrespective of the tools and techniques to address them. Distinguish which of these questions could be addressed with available experimental and theoretical tools in the coming decade and which could require new techniques or approaches. Suggest technical research areas that could provide particle physics with new tools needed to enable new techniques and approaches. Suggest different ways of thinking and alternative approaches from other areas of science that could be incorporated into and benefit the overall particle physics enterprise. Okay, so we spent a lot of time over these points, and we had to reiterate with DOE and NSF officials and NASM a couple times. But we at NSF are quite happy with these 4 points, and we will be very happy if the panel completely addresses those 4 points. So we anxiously await their report. So we certainly look forward to this very successful snowmass concluding here and a lot of documents for us to read. We anticipate the science drivers that will come out of the NASM study and the P5. And those are the ones that we at NSF can focus on best, I think, rather than the projects. So of course, our usual mantra, we respond to proposals, the community, which is you out here, drive where we go. But we also have other initiatives that push us in different directions. So some come from the NSF director himself, and others come from other areas like other areas of government. So these priorities, the ones that are most important for this community are DEI, which we've heard a lot about already today, quantum information science, and AI. So I'll spend a little bit of time going over these. So first, NSF's mission. So our new director, of course, is pushing for a new directorate, which is now underway, the so-called TIP directorate, Technology, Innovation, and Partners. This is driving much of what his thinking is, but of course, he's still pushing for the advance for the frontiers of research into the future. But also ensure accessibility and inclusivity and secure global leadership. So he's focusing on partnerships, people, and this translation, that's the TIP directorate, which translates the science into industry. So it's a bridge to industry. So that's his vision, and notice there's not too much directly connected to high energy physics in that mission. So DEI, so progress on diversity, equity, and inclusion has been an NSF priority for a very long time. Over the past few years, it's taken additional steps to enhance our goals in these areas. We have a large number of funding opportunities aimed at broadening participation in our field. There's new PIs, new institutions. Some of these have been in existence for a while and others are new. So we've had a couple new investigator workshops, learning about grant writing, so helping young people become successful in their careers, meet with program directors, et cetera. And then a couple of programs, which I won't go into a lot of detail, but MPS Ascends, which is a postdoctoral fellowship cohort building across MPS subdisciplines, and LEAPS, which is entry grants for faculty to initiate research. And both of those are pushing diversity, equity, and inclusion in the field. There's MPS High for current NSF PIs targeting high school schoolers in your research or high school teachers. AGAP GRS and Physics GRS for graduate fellowships. These are supplements to existing awards. All of these are pushing diversity goals. We have a new program, PREP, which is partnership between minority serving institutes and our physics frontier centers. That just concluded this year, and we've got a number of awards, I think 7 new awards, so almost one for every physics frontier center that's active. The physics division also has a special broadening participation funds, which has been useful. In fact, part of it went to funding participation here at this meeting. Many additional programs are being formulated And there are MPS-wide and NSF-wide initiatives that are coming in the near future on DEI. Okay, quantum information science, it's a big buzzword these days. And of course, we talk about it now because it's one of the places where there's probably new money coming and maybe it can benefit us, this community. Okay, you can click on this link. There's a good story there that tells about the history of quantum information science at NSF. But here are some recent developments. Of course, there's strong disciplinary programs in the math and physical science. Sorry for all the acronyms. These are all NSF speak, but that's the math and physical sciences and chemistry, materials, DMR, math, DMS, and physics. There's SIZE is the computing directorate at NSF, and then engineering. So there's disciplinary activities in all these divisions and directorates that's working on quantum information science. There are facilities and shared laboratories, infrastructure. Computing focuses on two awards there that are noted. I won't go into all the details here, but there's networking focus and a convergence accelerator. So these red ones are newer and they're more relevant to this community, perhaps. You've heard of the Quantum Leap Challenge Institutes. These are 5 awards that cover 4 sub-areas of QIS. I'll show on the next slide, one in bio. Quantum Foundries, these are 2 new awards in Santa Barbara and Montana State, Arkansas. Transformational Advances in Quantum Systems. So these are, again, awards that help push quantum science. And then there's workforce development, various programs, but I'll point out Expand QIS, which is a program that combines diversity with this initiative, namely the eligibility for that group is that you have to have not had some amount of funding from quantum before. So it's trying to get new partners in the field. Okay, so I'll just show you these Quantum Leap Challenge Institutes. These have some overlap with physicists that we know and love, but not direct. And each of these centers are a conglomerate of other centers. So I don't have all the locations highlighted on this map, but just the central one. So there's a Challenge Institute for Quantum Computation, QIQC, Quantum Systems through Entangled Science, Hybrid Quantum Architecture, et cetera. So, and again, there's one with biophysics. These have some connections with physics frontier centers and various other AMO type experiments. Okay, and artificial intelligence. Again, this overall link gives you a overview of artificial research, intelligence research at NSF. There are an ongoing number of institutes and growing number of institutes that were funded mainly by SIZE, but also partnered with various other divisions. And in particular, this is in 20 and 21, there's a program for 22 ongoing. But this one is the one directly related to our field here because it's the Center for the IFI, so-called IFI, Fundamental Interactions. This is the institute at MIT, Harvard, Northeastern, and Tufts. And if you download this interactive map, you can play around with this. So if you click on the IFI Institute, you find that it has partners all over the country. Okay, and so this is a summary of this AI Institute program. And I won't go into all the details here, but the initiatives have not, in the first year, they had a physics call out. So there was a theme that was basically AI and physics, but they have been less relevant for physics as the years have gone by here. So we haven't had any other one that's directly related to high energy physics. There was a Dear Colleague letter that the MPS put out. This resulted in a few eager awards. This is rather small, and it was meant as a bridge until we could figure out what MPS wanted to do with AI and AI institutes. It's not clear that they want to continue partnering with SIZE, for example. They may start their own program. This still doesn't clear what's going to happen next year. Okay, and I also point out that OAC, the Office of Advanced Cyber Infrastructure in SIZE, has funded these Harnessing the Data Revolution Institutes. That program is still ongoing, even though it was one of the big ideas from the last NSF director. And of course, one of the awards went to the institute here. Is it? Yeah, the award, the top one, Harnessing the Institute for Data Intensive Research in Science and Engineering. That's the call, and the award for A3D3 came out in September 21. So that is directly related to high energy physics. Okay, there are other different programs. The Physics Frontier Center, mostly not directly related to high energy physics, but indirectly. There's the new Center for Network for Neutrinos at Berkeley. This is almost all theory, but relevant to HEP and neutrino physics. There's the link to the IFI, and the Harnessing the Data Revolution one is at the bottom. But also US HEP has been around for a long time, so was a good use of size money to advance computing that's relevant for the Hyalumi LHC upgrade. And then, of course, I also mentioned the Science and Technology Center at Cornell for the Center for Bright Beams. So all these areas provide at least peripheral new money that helps advance the science that's relevant to HEP. Okay, so I just want to point out some sessions coming up. There are two. One is Wednesday. This will be more details of what we usually see in a sort of a HEP style talk where I talk about the budgets. As much as I can say, NSF has been really cracking down on what we're legally allowed to say at these meetings. So it's getting worse. But I'll say what I can about the state of the budget and where the money has been going. And then a special meeting, which I haven't announced to very many people yet, but this is really going to be particular to the experimental particle physics program and where I see this program going. This will be a discussion session. The Wednesday one will be a slide presentation followed by interactive discussion. I hope this one on Thursday will be entirely just a discussion session, although I may start it off with one or two slides to set the stage. And the stage is that we're under a lot of pressure to reduce the size of this program. I'll just leave it at that to pique your interest, and now you want to show up. Yes, yeah, no weapons are allowed. Okay, and that's it. So thanks. It's really nice to be here, seeing everyone in person. Be safe, and please write all those reports for us to read.
Thank you, Jim. So again, we're going to reserve questions till the end. Our next speaker is Harriet Kung from DOE, and she is the Deputy Director of Science Programs in the Office of Science, and she is also the Acting Associate Director of Science for HEP, which I think means you report to yourself.
That's correct. Yeah.
Sounds like a good deal.
Yeah. Good afternoon. Hope you can all hear me well. I'm really, really honored to be here representing the Office of High Energy Physics. I first would like to thank the very, very talented HEP team who have put the slides together. If I could invite all of my HEP colleagues to either raise your hand or stand up, we actually have probably 6 or 7 program managers if you're in. This is actually represents a very active participation, COVID notwithstanding. So I really encourage all of you to interact with our program managers who are really passionate and strongly supportive of this program. So let me quickly go through, actually, is this? Okay, all right. So just quickly recap some of the backdrop of the P5 study. Here are kind of 3 key points from the 2014 P5 reports. The first 2 really speak to the globalization of the community. First of all, the ambition and the aspiration to address some of the most compelling questions of the field is really beyond the financial or technical capabilities of a single nation or single region. But I think the second message is equally important, the affirmation that the ability to address these questions in a comprehensive manner through a global collaboration is within reach. But the third key message, which is probably equally important, is the field was at a juncture where major players each plan to host one of the more larger projects. So if we consider today as we're ready to launch the next P5 study, I believe that all three key messages are still valid. Probably even more complicated is the geopolitical situations that we're facing now that actually make the next P5 study even more challenging. But I think that we're in very good hands given the community are really passionate and eager to help us launching the next study. So with that as the backdrop, if we look at the current HEP program, in FY22, our budget is over $1 billion. That actually represents about nearly 50% growth since about 2 decades ago. And we continue to be the largest supporter of particle physics in the US with very large footprint in terms of the institutions, geographical distribution, as well as the direct support to researchers, PhD and graduate students, as well as the users that access our scientific user facilities. In terms of the funding, we're actually reaching a point where our research is about 40%, and that is kind of the average of the science programs has had in terms of research, with the remainder 60% split between the facility operations and the project and so forth. So with that as the kind of the at a glance, in the wrong. So let's delve into more details of the HEP program. So shown at the top are the budget information. So since 2020 to now we have seen the 2023 house mark, the program actually has enjoyed a very robust, substantial support with close to $100 million for $1 billion program. That's about 10%. And if you look at the two major categories, the HEP research, it's really holding steady actually with a very promising, encouraging growth in 2023. And the research actually cover both the research and also the facility operations and our support for major item equipments projects. And the line item construction, which actually has enjoyed very robust support, is actually steadily increased to close to 300 million. So if you look at the key components of the HEP program, of course, the centerpiece is our core HEP research. And our major mission is to drive scientific discovery. And as a result, we support a very robust and comprehensive theoretical and experimental activities. And in addition to that, I think we have heard earlier, there's been increasing emphasis on broadening participation. So currently we have a dual track. One is we actually establish an office dedicated to DEI by changing the culture, putting in processes and procedures to overcome implicit bias, but really trying to increase the awareness of pushing for the goals established under diversity, equity, inclusion. But separately, we have put additional funding opportunities to broaden the participation, especially increasing participation from underrepresented and underserved community, which we'll talk about later in more details. But in addition to the core research, we're also firmly believe that in order to build the future, robust future of the program, we need to continue to invest in not only building R&D capacity, but also driving technology innovations. A lot of the foundational support from theory to accelerator detector R&D to various other what we call the industries of the future, and that's actually reflected in the next bullet. There are a number of administration priorities. I think we have heard from our NSF colleagues, from QIS, AI machine learning, and others. So since the previous administration, there's a set of what we call technologies or industries of the future that have received a lot of support. So the high energy physics community in DOE's Office of Science also had taken full advantage of the infusion of funding that's coming to the department. But I think the key in the HEP portfolio is that these opportunities are indeed critical to the future of the high energy physics program. Not only these are infusion of funding, but really serve the purpose of enriching, but also diversifying the core research program in high energy physics program. For example, take quantum information sciences. I think our colleagues in NSF also has similar example to show. I'm actually very, very proud of the HEP program, where they have been the front runner in pushing for quantum information sciences, not just because of the need to use quantum computing or quantum sensor to push the mission that's very complicated, the portfolio in HEP. But they also feel like there's a lot of the technology advances that really have grown out of the capabilities, expertise from superconducting qubit to cryogenic to control. So this is really a very, an excellent example of how HEP could benefit from these additional resources, but using it as a way to further enrich, broaden the mission space in HEP. And artificial intelligence, machine learning is yet another excellent example, where by necessity, the complexity of your experiments, the data set, the data rate, all need to push for additional advances in AI machine learning. But I think the question now is, as we are growing our core research program, by absorbing these new additional funding, whether we can retain the cohesiveness of the overall core research program. I think that is a challenge that the next P5, the SNOMAS in the next P5, hopefully will help us address. So in addition to research, we also have a very robust program supporting facilities. This includes the Fermilab Accelerator Complex, the FACET-2, and also our continuing investment in infrastructure such as the Stanford underground research facilities. And the next bullet is actually in direct response to the previous P5 report. Remember, there are a number of really exciting projects, and through the community support, through the administration support, through congressional support, we are now actually supporting a very robust and diverse pool of projects from LBNF Dune, PIP2, Mu2E. These are the line item projects, but also a number of what we call major item equipments from the Halumi LHC accelerator and detector upgrade projects to Acorn, which is the accelerator upgrade at the Fermilab, to the CMBS-4, the cosmic microwave background stage 4. But in addition to these line item and project and MIE, we also have other very exciting projects that are cited and not at DOE laboratories. And this actually include the ATLAS CMS experiments at the LHC, the SURF and LZ experiment, the Vera Rubin Observatory, Chile, DESI at Pete, and also experiments at Canada, Snow Lab, Japan, and even on the International Space Station. So all in all, for $1 billion plus program, this is really extremely exciting, but really diverse program. And continue to set priorities while retain a very bold and exciting vision. I think that is also a key task. The SNOMAS and also the upcoming P5 will hopefully help us set the priorities. So this is one of the first, the two budget slides I want to share with you as a way of showing the impact of the 2014 P5. You can clearly see a before and after P5 2014. So up until 2014, the budget has been relatively stagnant, but the 2014 report, having that one unified, really compelling, exciting voice depicting a exciting vision for the program really has helped HEP to position this program and has since then enjoyed very robust growth. And we not only have sustained the core research program, but then have also increased a lot of the funding, especially in the project space from LBF-DUNE, Mu2E, PIP2, and also the Halumi LHC upgrades and so forth. But the impact is probably even more prominent and pronounced if you look at the longer time scale. This is actually funding since 2000. So one thing to note is that especially in the decade preceding the previous P5 report, the HEP project program actually not only has maintained a stagnant budget, actually some year actually the budget has come down. And a lot of the factors have contributed to the budget trend. I think Steve mentioned earlier, we have several of the facilities closure, from Tevatron to PEP2, and some of the funding have been taken up by increases in research in some of the preceding years, but those increases had not really stayed. But then not until 2014, we have now starting to see very robust and substantive growth in the HEP project. And of course, a lot of the growth has been driven by the projects that have been identified in the previous 2014 P5 report. So one question, and people may actually ask, is what if the growth in these projects has really hindered the other components of the program, from research to facility operations? However, based on my 20-year or so of budgeteer experience, I can actually tell you that there's really no guarantee that the funding that has gone into supporting the project would have stayed in HEP. So the moral of the story is that each and every single of these components would really need to justify, defend its individual compelling foundation for the robust support. And probably even more importantly, is the different components really need to be stitched together to paint a really compelling, bold, ambitious vision for the program, for you to really sustain the growth in this community. Because the competition is not within HEP. It's the competition is really with many, many other programs. Just imagine the preceding decade before the 2014 report, at least 2, if not 3 other programs in office science has increased their budget tremendously. However, if you hold on to a vision, a divisive view of your community, you will not be able to enjoy the level of support like some of the other programs. So this is actually a key message I want to leave with you. Okay, so let's see quickly, 10 minutes, okay. I think I should be fine because Andy Lanford essentially gave my talk in his view about the scientific program. But let me just quickly mention a few key elements of the HEP program. Of course, as I mentioned earlier, LBF-DUNE and PIP2 have been the major funding and budget driver for the HEP program. I just want to start by saying that the vision of LBF-DUNE and PIP2 to build a signature flagship facility, that commitment is still true to this day. And these combination of projects remain the highest priority in office science and high energy physics program. However, we also want to say that the vision of building this global partnership is really in a strong response to the previous 2014 report. And we firmly believe that the successes of the LBF-DUNE and PIP2 relies on the strong partnership between the United States and our international partners. On a daily basis, we have seen how meaningful and substantive these partnerships really is delivering progress from capabilities to facilities to experiences. And we especially like to acknowledge our partners as CERN, France, India, Italy, and UK. In addition to technical contributions, we also have enjoyed very strong financial contributions, close to $1 billion combined between these two projects. However, as any major complex projects, it's inevitable that we encounter challenges. And that's exactly the case we have seen, especially in the past couple of years with LBNF Doom. So what had happened in the past couple of years is we have devoted substantial human resources, technical resources to make some very significant changes to the project. But first of all is to reorganize the project into the sub-projects modality. As it turns out, for a very $3 billion plus project, there are different components. If you wait until all components to mature for you to move to the next stage of the project management, you will actually be limiting your option, you will limiting your oversight, you're limiting the decisions that you need to make to quickly make corrections and make decisions. So the reorganization into sub-projects seem to have paid off. And actually later you will hear from Leah's talk about some of the details of the LBNF2 project. But in addition to that, there's also improvement in the oversight that has been applied to the project. Secondly, we have worked with senior management in Department of Energy to actually find new funding guidance. And the new funding guidance has significantly improved the project schedule, reduced the risk, and a lot more responsive to the partners and also our community's concerns. So in the end, we still firmly believe LBNF and PIP2 will enable Dune to be the first-in-class experiments. And we also anticipate that additional upgrades, further capabilities could likely be considered in the next P5. And many of you are aware that last week we had a very thorough review as the LBNF Dune project will enter into their rebaseline of the, not rebaseline, the CD1RR is the re-evaluation of the alternative analysis, the critical decision one. And I'm very happy to report that we have received recommendation to proceed with the CD1RR decision later in the year. However, the committee did recommend that it was us to seriously consider reevaluation of the total project cost and the cost range. These are primarily driven by several factors. We're not out of COVID yet. We have seen historically high level of inflation. In addition to that, we have also seen some very strong supply chain disruption. So all in all, I think the project has made very significant progress in stabilizing various cost and schedule concerns that were surfaced earlier in the project. And we're confident that the project is in a very solid trajectory moving forward. And the details, Leah will I'll go through that. So let me quickly, since Andy already covered a lot of these, maybe I can just quickly go through the intensity frontier. We're especially pleased to share, I think many of you already know the first muon G-2 results, where I combined with the earlier Brookhaven results, really offer some tantalizing clues about the significance of the standard deviation. And of course, we're looking forward to additional analysis. Of course, energy frontiers. I think this is the LHC at CERN continues to be a centerpiece of the US Energy Frontiers program. And it's an integral part of the US DOE HEP program. We're especially proud of the CMS Atlas results of today, over 2,200 publications, and also the start run since the start of the LHC running. The recent celebration of the 10th anniversary of the Higgs discovery, and also anticipate during the run 3 additional very exciting results. We're also very pleased to see the high Lumi LHC accelerator and detector upgrades proceeding well. Many of you, and we have heard throughout the day about the very exciting futures of facilities. And we are actually working very closely, not only within the department, but also outside the department with US State Department, also OSTP, to continue to coordinate, collaborate on two aspects, especially collaborating with CERN and our other global partners in the feasibility study of the FCC. We also continue to monitor the ILC status, getting ready to step in if there are possible movements there. And of course, we look forward to SNOMAS input to the science reach and ambition of these very exciting prospects of the future colliders. Cosmic Frontiers has grown into a very exciting and critical part of the HEP program. And I think Andy has covered many of that. And the LZ's first results, especially encouraging, even though just after 60 days of data taking, we already are setting the most sensitive limits over very large mass range of the weakly interacting massive particle WIMPs. A few words about, even though these are not the Frontiers program, but I think the foundational pieces, I really just cannot overstate the importance of advanced detector accelerator technologies, its impact on the future health of the overall community, not only serving as the backbone of your experiments and your facility, but some of these advances not only impact high energy physics, but also the field broadly, from the advanced detector technology to high field magnet to the superconducting RF. And this is actually coming from the condensed matter physics community, LCLS, LS2, LS2HE, and plus FRIP, all are the beneficiary of the really innovative processes and leadership HEP has demonstrated, advanced accelerated concepts. As we going into the multi-TeV collider, how do we really utilize the most tantalizing prospect in these plasma wave field technologies, and other advances are going to be key. So theory, actually, if I can spare me this, I really would like to take this opportunity to highlight Jim Segrist. I would call this the Jim Segrist legacy. He firmly believed the theory program, and that actually speaks to the power of being a bureaucratic Fed, because he could really influence the field. I think Jim, earlier in his tenure in also science, saw the really important role theory can play, and he then worked with the team to build and grow this program. I think the next P5 hopefully will guide us in an additional role theory can play. And similarly for core research, I think I do want to mention one very key point, which is the interwoven nature of core research, facility operation, and the project design. I think that's very unique in the HEP field versus other physics field that Office of Science stewards. Your experiments really require that interdependency. And we have seen that just by growing the project funding without companion growth in research or in companion growth in facility operation, will limit the future growth of the, and that is something that we are hoping, we're already taking steps to address, but hoping that the SNOMAS and the P5 could also help us with that. So let me quickly, 2 minutes, okay. Key elements of successful P5. We look at the success of the last study, well informed by the science community. I think Steve has mentioned that it's a messy process, but every voice counts, and having that going through that well informed process by the science community really made a huge difference. You had to set a grand long range vision, face budget constraint realistically. Community made tough choices. That is something congressional leaders especially appreciate. The tough choice have to be made by us. And while we're making those tough choices, we have to make sure that we have a balanced portfolio. And the last is especially key, community engagement, critical success. And the last quote, maybe from Jim Segrist, or even could be attributed to Pat Damer, bickering scientists get nothing. Keep that in mind. Bickering scientists get nothing. As you get into the P5, SOMAS and P5 process, coming up with a unified, compelling voice is critical. So I can skip this. So the last P5, we have really a very robust, comprehensive but also very thoughtful process from the before P5, well informed by the science community. Communities stay engaged throughout the P5 process, even after the P5 report is rolled out, including targeted engagement, as Steve mentioned earlier. Those are really, really key. But I think the last part is even important, is that through even after the release of the P5, continue updating it, engagement, and inform the community as the progress. That helps the community to stay on the radar of the decision makers, but also show that what you have delivered since the resources being applied to you. So let me just quickly mention, I think already my NSF colleague already has mentioned, there are several pieces that are feeding into the next P5. The SNOMAS will provide the community scientific vision. We have the NASM, the Cato survey as an external independent vetting of the science, plus broader or new perspective. We also, thanks to Joanne, we have the next PPAP, international benchmarking, where they kick off, hopefully will inform the global nature of the program. So let me leave you with this. I agree with Steve that facing a realistic budget scenario is important, but without a grand, long-term, exciting, bold, ambitious vision, realistic budget will get you nowhere. So vision is very, very critical. And then you make tough choices, you make prioritization, you make a balanced program. We also would like to strongly encourage you all to consider a balanced portfolio, small, mid-scale, and large projects. But the next bullet is key. Please do take serious consideration, not only the project costs. Once the project are done, there's very substantial operating costs. There's also, we need to continue to invest in research program to be able to take advantage of the facility, but also to pave way for the future technology R&D for the future. So again, community engagement, including this week's SNOMAS study, will be key. And really would like to thank the organizer of the SNOMAS process, but really this is going to be a long and torturous road. We look for strong partnership with community. We really need your input. We need your support. We need your unity to help advance the whole field. So with that, thank you very much.
Okay. So the next speaker will be Leah Merminga. So hi. Who is the new director for MELAB. And my boss.
What on? Yes. The drop it down buttons forward. Other one.
Okay, very good. Okay. Hello, everyone, and thank you so much to the organizers for inviting me to give this presentation. So when I thought about the title of my talk, Building for Discovery came to mind, as you will see. It's going to be self-evident. So a very quick overview of Fermilab. Fermilab is our National Particle Physics and Accelerator Laboratory. It operates the largest US accelerator complex and second largest in the world. It has about 1,900 staff and on the order of 600 million per year budget. It sits on 6,800 acres of federal land, and the facilities are being used by more than 4,000 scientists from over 50 countries around the world. And as we move into the next 50 years, our vision remains to solve the mysteries of matter, energy, space, and time for the benefit of all. And so to do this, of course, we rely on our core capabilities, which include accelerator science and technology, advanced computer science, visualization and data, of course, particle physics, and large-scale user facilities and advanced instrumentation. An integral and essential aspect of our mission is our research community and hosting it and nurturing it. As we mentioned, we have more than 4,000 scientists from 55 countries come to Fermilab to use the facilities and the computers and the detectors for their research. And this includes more than 2,200 scientists from 175 US universities and labs across the country. And part of this is Fermilab is attracting and training the next generation of a diverse HEP scientific workforce with more than 100 postdocs, nearly 300 graduate students, and more than 50 undergraduate interns. And as we welcome scientists to Fermilab to do the research, our scientists go around the world as well to do their research, including at CERN, at the CERN facility in South Dakota, Snow Lab in Canada, South Pole Telescope, Ash River Laboratory in Minnesota, and so on. And our core mission for the lab is following and executing the 2014 P5 plan. The flagship projects, LBNF Dune PIP2 and the high LUMI LHC upgrades, anchor the program, but as we know, they take many years to realize. Simultaneously, however, Fermilab pursues a broad research effort in high energy physics, and the goal, as the P5 report wrote, is to have a continuous stream of exciting results that attract and build and retain a diverse user community and a scientific workforce. And we'll talk about that in a minute in more detail. And as we heard from Harriet, Fermilab projects drive funding growth for the entire HEP, as Harriet told us a little earlier. So let me in the next few minutes give you an overview of the major science and technology initiatives and share with you our vision and our priorities for the laboratory. And they follow this, they more or less map. I'll use these categories, but they effectively map into the P5 drivers. So Fermilab's highest priority is the completion of the LBNF and Dune endeavor as a whole. And Dune is going to be the world's most capable neutrino experiment, driven by the long baseline neutrino facility and the PIP2 upgrade of the Fermilab accelerator complex. Our vision, when LBNF and Dune is complete, is that US and Fermilab are universally acknowledged as the world leaders in neutrino science for decades to come. And PIP2 is the upgrade, as I mentioned, to the accelerator complex to enable the world's most intense beam of neutrinos. LBNF is the dual site, long baseline detector facility with caverns at Fermilab and in South Dakota, 1 mile underground to house powerful detectors. And Dune is the experiment itself, which is a next generation neutrino experiment based on liquid argon technology, detector technology. The scientific objectives for Dune are truly profound and include understanding the origin of matter by investigating leptonic CP violation, neutrino star and black hole formation, and the unification of forces. And I'd like to point out that LBNF and Dune is the first internationally conceived, constructed, and operated mega science project hosted on US soil by the Department of Energy. So as I mentioned, LBNF and Dune US sits on two sites. Near site is in Batavia, Illinois, and far site is at the Sanford Underground Research Facility in Lead, South Dakota, where the near site includes the primary and neutrino beam line, upgradable to 2.4 megawatts, and the contributions to the near site detector. And the far site includes caverns, the excavation for the caverns to host 4 very capable detectors, infrastructure facilities, cryogenics, as well as the US contribution to 2 of the far site detectors. The Dune collaboration is managed by the the Dune experiment, sorry, is managed by the International Dune Collaboration. It has right now more than 1,400 members from many institutions and 37 countries around the world. Gina Ramica and Sergio Bertolucci are the co-spokespersons. You see the demographics here, and Fermilab is preparing ourselves to host the entire LBNF and Dune, let's say, endeavor, as well as the Dune collaboration. So to that end, we have already established an international engagement office to coordinate with our international partners. And we're in the process of putting together a host lab task force that's going to be headed jointly by the 2 deputy laboratory directors, the deputy director for research and the deputy director for operations. And this task force is going to delineate what it all entails to be the host lab for the entire Dune collaboration. They are going to complete their planning at the end of this year, and then we're going to work together with HEP to execute the plan. So we're taking this very seriously, and we want to be ready starting in 2024, both at Fermilab and at SERF, to welcome the international community to do neutrino science here. So I'll give you a brief update now on how the project is going, LBNF Dune US and recent achievements. So as we heard from Harriet, the project is being executed through 5 sub-projects. The total TPC has been stable since roughly 2019 at 3.13 million. 3.13 billion. The far site excavation is proceeding on time and on budget. At the moment is about 33% complete, and it is in the baseline approval process. Is up to baseline. The far site excavation sub-project has been scheduled in July this month, and the detector installation begins in 2024, and CERN and our partners are ready for the production and to come and start to install detector equipment in the far side. As we heard from Harriet again, and we're very grateful to DOE for providing a new funding profile to the project, which accelerates the beam on date to LBNF, to Dune, to March of 2031. And this is significant acceleration compared to the previous profile. It reduces several risks, and it is very much aligned and responsive to our international partners' schedules, as well as addresses concerns they had. And here is a photograph, a couple of weeks, I guess it was last week. The new director of the Office of Science, Dr. Berge, that you see here, visited the far site, and And so this photograph is taken at 4850 level underground. And she spent quite a considerable amount of time visiting the facility over there. And this is the open cut where the rock that's being excavated, which is going to be in the end 800,000 tons, is being deposited. And when LBNF excavation is all done, only 1% of this huge open cut is going to be filled. And so, as we heard, these past few days, we had the CD1 reaffirmation review. Okay, sorry. Okay, all right, I'll stand still here then. So, so we had the CD1 reaffirmation review, July 11th to 15th. And here I've summarized a number of key takeaways from this review. The first and most important message was that the review committee of about 30 experts expressed strong support for the competitiveness and complementarity of Dune with Hyper-K. And this is a very important message, especially as this review considered the analysis of alternatives. Second, they recognized considerable improvements across the entire project, which includes the new funding guidance from the Office of Science that we talked earlier, significant technical progress across all 5 sub-projects, and we talked about the far site excavation, which is 33% complete, a positive change in the project culture and atmosphere. They used words such as open, transparent, and disciplined, which is also very important. Verbatim, they said the project team is the strongest that the committee has seen on this project, working well and focusing on the important issues. Furthermore, the design and build to cost strategy with not to exceed cost constraint that they had recommended in an earlier review is starting to have a positive impact. And also they reiterated there is a need to constantly reinforce and execute to this approach, which is what we intend to do. And they validated our vision for Fermilab to be the host lab for LBNF and Dune, the program and the collaboration. And they also acknowledged that the focus of the entire laboratory organization to give priority to LBNF and Dune were not worthy. The project costs are understood and stable since about 2019 at about 3 billion. However, as we all know, we do live in extraordinary times right now. And just like all other projects within the Office of Science, LBNF and Dune also experiencing the external conditions such as impacts from COVID, from inflation, supply chain, and so on. So the committee recommended that we continue to work together with the HEP program in order to evaluate and estimate the cost and schedule range and then proceed to CD1 RR, which we plan, ISAB, which we plan to do later this year. And I'd like to say here that it is our strong preference to try to keep the total project cost as close to 3.13 billion. And we're going to explore multiple ways to do that in order not to burden the program and the system overall. So moving on to PIP2 now. PIP2 is an international accelerator project, and the upgrade, maybe I should point out, PIP2 is going to sit to sit on this side of the Wilson Hall, as shown here. This is the cryogenic plant building, which is already almost complete. And this is the Lina Gallery, and the accelerator will be housed in a tunnel underneath the Lina Gallery. So the project received CD3 approval for construction April 18th, and the Lina complex RFP has been issued already, and we expect to begin construction this fall. The Kraupland building is complete. We have built the front end of the accelerator about roughly 20 MeV, including the first two types of cryomodules, and we've accelerated beam that satisfies the PIP2 requirements, all except, of course, of energy. So we have validated the front end of the machine, and we are now building the high beta 650 prototype cryomodule together with our partners. You can see here Olivier Napoli, originally from CA Saclay, who is visiting. This is a first of its kind cryomodule, and it does take advantage of the advances in superconducting RF that we have done at Fermilab. And PIP2 is the first particle accelerator built in the US with significant contributions from international partners on the order of 300 million. And most importantly, it is the expertise and the experience and the capabilities that these international partners bring to us that is even more valuable, arguably. And one word, I guess our numbers differ a little bit, Harriet, we need to scrap this, but between LBNF, PIP2, and Dune, the in-kind contributions, they are on the order of $1 billion, with 260 roughly towards LBNF, 400 to Dune, and about 300 to PIP2. And here I'd like to point out that Fermilab is breaking a new ground in putting in place the framework that allows us to receive and accept and work with the partners at that scale. And we've done, of course, that in collaboration with DOE and other agencies. Moving on, as the P5 report told us, we need to have an integrated neutrino program. So to that end, we have launched the short baseline neutrino program, which goes in parallel to the long baseline program, NOVA, and eventually Dune. And the goals of the short baseline program are multifold: to attract a national and international community to Fermilab that's going to move from the short baseline ultimately to Dune, to perform experiments with the liquid argon detector technology and validate that, because that's technology used for Dune, and to establish and train a diverse community of researchers that are needed for Dune. But very importantly, SPN has a compelling scientific mission in its own right, and its scientific mission is to resolve the 4.8 sigma mini-boon low energy excess with the possibility of discovering sterile neutrinos. And recently there were some important news that took a lot of publicity. Moving on now to Collider Science and the US CMS collaboration. Our vision here is that Fermilab continues to be the leading US center for CMS and the second leading center in the world after our partner CERN. Here I'd like to make an important comment. CERN is not only our European sister laboratory, it is our strongest partner in so many ways. For more than 2 decades, Fermilab has played a significant role in the LHC. Now CERN is playing a significant role in Dune. And Fermilab, in addition, is host of the US CMS, which is 27% of the entire CMS collaboration. Our capabilities in terms of accelerator and detector R&D have enabled us to contribute to construction of the high Lumi LHC upgrade projects, both on the detector and on the accelerator. And as well, we very much look forward to contributing with R&D to the future circular collider at CERN as well. And in the interest of time, I'm going to skip, except to point out the recent, of course, W boson mass result, which turned out to be in tension with the standard model, and there was the publication in Science. Importantly, Fermilab is the host laboratory for US EMS, and as such, it hosts a tier 1 center facility, a tier 1 facility, which is the world's largest outside CERN, and in addition, contributes to R&D on computing and software and exploits high performance computing. We also host the LHC Physics Center, or LPC, which is established as a center of excellence with missions on research, training, and user support. And one important message is our remote operations center is back in operations, and starting next month, we're going to welcome the community to come and sit in our ROC and take data from the LHC operating. And of course, that has a lot of benefits and for the entire community. And it has been, we have not been accepting users so far, but we're opening up again. So that's important. Precision science, our vision here is that we are a world center for accelerator-based charged lepton flavor violation and dark matter experiments, driven by the intense beams that we have at Fermilab, and even more that will produce with PIP2 and the booster replacement. As you know, we have 2 facilities. NEON G-2 is in operation, and previous speakers spoke about the results. And then NEO2E is a new experiment under construction with the expected completion date 2025. And when we have PIP2 and the NEON campus infrastructure in place, that will enable us to even higher precision science experiments. For cosmic science, we aspire to be essential partners in world-leading endeavors about cosmic science experiments, including cosmic microwave background. And we also want to contribute to a coordinated campaign of experiments in the laboratory to detect and to study the properties of dark matter particles. And we have some unique capabilities, including the silicon detector facility, sub-Kelvin low background cryogenic facilities such as Nexus, and of course the new integrated engineering research center that are going to be of service to the entire community. Accelerator science and technology is enabling technology. We want to remain world leaders to enable the next generation of particle accelerators and to advance the mission of the Office of Science as a whole. And we also, of course, want to pursue accelerator science as a science in its own right. And to that end, we house a unique facility, IOTA and FAST, which is a unique platform for accelerator science. And recently, we had the world's first experimental demonstration of optical stochastic cooling in this ring with a publication accepted in Nature. And our capabilities on accelerator science and technology span accelerator and beam physics, superconducting RF and cryogenics, high field magnets, and high power targetry, very important for LBNF and for the muon production capabilities. And of course, we want to modernize our facilities, lab spaces, control systems. And to that end, we have initiatives such as ACORN, which is for a new control system for accelerators, and a robotics initiative, which is actually quite cute. Those were the major S&T initiatives, but now we have three primary emerging science and technology initiatives or capabilities that include quantum information and our SQMS National Quantum Center. Let me just go quickly here. So the vision for our quantum center is to develop and deploy Fermilab's first quantum computer enabled by our expertise, our own expertise in superconducting RF technology and cryogenics, and ultimately use this computer to enhance HEP research back again, and also to demonstrate qubits of superior performance, which are then can be transferred to industry. And I have some information here. The second emerging initiative is AI and machine learning. 3 primary thrusts here. One is AI on a chip, real-time fast AI integrated into the sensor. Second is AI machine learning for optimal operations of accelerators and experiments. And the third is uncertainty quantification and bias. And the third is microelectronics and detector R&D. We have developed expertise in microelectronics, in cryogenic electronics because of the needs for Dune. And now we use that to expand in collaboration with other institutions. And in 2021 received an award for microelectronics co-design research. We also have a detector R&D strategic plan, which puts emphasis on 2 thrusts. One is picosecond timing. The second is detectors using liquid argon and xenon. And we house the Fermilab's test beam facility with a new irradiation test area, which is also in the service of the National Detector Program. So all of this, so now you see why I called it building for discovery. That goes very well for Fermilab. So Fermilab truly executes the P5 plan. I've listed here all of the projects that we're executing right now. Those with the P5 sign directly come from the 2014 P5 report. There are some others, but and the message here is that there is, as more space becomes available, then the next generation, I guess, and the next P5 plan is going to fill those gaps as they become available. But our focus, if it's not clear so far, is executing and completing the P5 vision in a timely manner. So, and of course, securing a vibrant future for US HEP with Joel and a lot of participation in this meeting. So I'd like to summarize here with leave you with the following thoughts. As in the past 2-3 months, as I'm trying to understand our program, I've come to realize that our mission is strong, compelling, and beautiful, and our community as a whole is truly world-class, including, of course, all my Fermilab colleagues. And Fermilab, along our national and international partners, remains laser-focused on executing the P5 vision. LBNF and Dune is our highest priority, and through partnerships, we're building a highly capable, world-leading neutrino program, which is going to secure US leadership in a key element of the global particle physics program. And going forward, we, of course, are very actively involved in SNOMAS and following towards the next P5 plan. And this next point is the intellectual vitality and the open and inclusive culture of Fermilab must be retained because they are essential for the health, not only of the laboratory, but of our field as a whole. And so I had not coordinated with Steve or Harriet, but my message is the same here. by defining a bold yet realistic vision and a new strategic plan with P5, together we can ensure that US remains a global leader in high energy physics. And I'd like to conclude by thanking you for your support and commitment, thanking, of course, DOE and our international partners. And I want to invite you to come back to Fermilab, please. So thank you very much.
Thank you. And our next speaker is Joanne Hewitt, who is the research director at SLAC and is also the chairperson of the HEPAP subpanel. Panel, excuse me. Getting late.
How do I advance? I click?
You can click or keys or the.
Oh, the button, the keys work? Oh, cool. Okay. Yeah, that's cool. Okay, good evening, everybody. As everyone has said today, speakers always start their talks out with, oh, thanks for inviting me. It's a pleasure to be here. But today we all really mean it. It is truly a pleasure to be here. It's a pleasure to see each and every one of you in 3 dimensions and remember how tall you are. And, and to just bump into you without planning a 30-minute Zoom meeting for it. So thank you. The advantage at speaking last of the day is that my talk's been mostly given by everybody else during the day. So hopefully I can make up some time because I'm acutely aware that there's not only me, but a panel discussion standing between you all and dinner. I'm going to start here at the end of the last P5 report. And as has been said many times today, it's just been extraordinarily successful. The report has spawned numerous international agreements, more than you can list on a page. I forgot how to use a laser pointer. I put this picture here. I particularly liked it because it showed that the pandemic didn't stop any of us. We're still signing international agreements over Zoom. The budget has grown tremendously, really beyond our expectations. The Office of Science as a whole enjoyed a spectacular budget growth during this time frame, and the success of the P5 report and the plan and its welcoming reception is really what helped high energy physics capture our share of that growth. So that was a very important achievement for us. Click the slide. You told me the arrows would work. But I moved the thing. Okay, now I'm clicking the slide and I'm getting pop-up windows. Oh, do I left click? Yeah, left click. There you go. Oh, the arrow keys work. Windows. Okay. So HEPAP, the P5 plan was building for a decade and it came out in 2014. And so a decade was sort of till 2024. And so halfway through in 2019, HEPAP took a year-long assessment on the progress that was being made on the plan, both by the community and our efforts in terms of executing the plan and the agencies in their efforts in implementing the plan. We looked at the status of the science drivers. Science is not static. We expect it to be dynamic. We expect things to change 5 years in. Are these still the right questions? Are these still the most pressing questions? And we looked at checks and balances in terms of carrying out the plan. The report here, that the link for our is just a short one-pager summary of our evaluation. You can go to our HEPAP webpage and see all of the beautiful talks that all of the representatives from all the different P5 projects gave. Our one-page report can be found at this link. And let me, just hit a couple of highlights of the conclusions here today. First and foremost, these 5 science drivers continue to describe the most urgent questions in our field. P5 did a great job with the science drivers that, of course, was built on these 11 to 30 questions from the 2013 snowmass. Both of our agencies, NSF and DOE, have very closely followed the advice given in the P5 plan, and they've been very successful in managing to execute the plan. One thing that's kind of hidden in the details of the P5 plan is that the construction of LBNF Dune and how exactly that would take place and what exact time frame and funding was a little bit murky. And the construction for this project is further along than envisioned by the 2014 P5 report. And this is thanks to the generous support from the Congress and from the DOE Office of Science. The timely construction of this project is critical to achieving our national priorities. And in this report, there's a science target date for 2035. And I think the number is 120 kilotons times megawatt times years in terms of protons on target there at SURF. And lastly, for the assessment conclusions, I'm just going to read out this paragraph because I think it's very important. While investments over the past 5 years have focused on construction, it will be important to balance the components of the AGP budget to continue successful execution of the plan. Operations of newly constructed experiments require full support to reap their scientific goals. An AGP research program needs strong support to fully execute the plan. What this is really saying is that the plan cannot be executed without the people to do it. It needs you. We need folks to build the experiments. We need folks to operate the experiments. We need folks to interpret the experiments. And we need these folks to be supported. So 8 years into the plan, what's our report card? This is this eye chart here. This is the list of the P5 projects from all of them, okay, small to large. Time ordered, this is a slice in time with the start of 2015, which is when the P5 plan really took into effect here at the left, all the way out the decade to the end of 2024. And it's really exciting when you take a look back and you see how far we have actually progressed with these projects. 8 of these projects have been completed and are now in operations or commissioning. In particular, 4 of them received their CD4, which is basically the completion of fabrication during the pandemic, with DESI and LZ in 2020 and Facet 2 and LSST CAM in 2021. 4 of the projects are now at CD2 or 3, which means they've been baselined or under construction. 3 of the projects are at CD1, so they're preparing for baseline. And there's 1 project still at mission need, but ready to move forward. There's also been a broad portfolio of smaller projects as envisioned by P5 and put into the plan that have successfully executed and brought about science. And just to get a sense of what we have accomplished in these last 8 years, for the 8 projects that have completed in transmission and transition to commissioning our operations, here's the results. This is really cool. And in putting this together, I realized just 1 plot per thing. It covers all 5 science drivers. You've got Higgs, you've got neutrinos, you've got the dark matter plot that's 10 days old. You've got cosmic inflation, and you've got exploring the unknown. You even have accelerator R&D. So the breadth of what's been accomplished and completed since the last P5 is really tremendous, and it's due to a lot of hard work from our community and support from the agencies. And again, science is not static, it's dynamic. There's a lot of new programs and initiatives. Others have spoke towards these during the day, so I'm not going to really say much except that Some of the largest ones in terms of impact in our field have been QIS. We've heard a lot about that today. QIS, we've been able to use our HEP technology to advance QIS, and we've been able to apply those QIS advances to advance our own HEP science. Machine learning, very important for us. The dark matter new initiatives, this has opened up, as Satoshi said this morning, to orders of magnitude of increase in terms of where we can search for dark matter candidates and microelectronics. And last on the list, but certainly not least, is the effort to renew our workforce. And I hope everyone here is thinking of proposals to submit to the funding opportunity deadline that's this summer, August, I believe. So here we are, starting out on the path of our new strategic plan. How do we know that the time is right? Well, one way to tell is to go back to this eye chart and look at what the colors mean on these bars. So the green bars are experiments that are currently operating, or if you like, yesterday's projects lead to today's science. Okay. The blue bars are the projects that are currently under construction. So today's projects lead to tomorrow's science. And then the yellow bars are planning for the next decade. A healthy program really needs a mix of all three. It needs a mix of the scale of the projects from small, medium to large scale. It needs a mix of the scientific portfolio from all of our different frontiers, but it also needs a mix of the stages of the experiments that are being built. You look at 2014 or beginning of 2015 here at the end of this, you see that there really wasn't a lot of green. We really didn't have a lot of blue, but boy, we had a lot of yellow, okay? We had a lot of things that were in planning mode or R&D mode, and we're not yet ready to move forward to fabrication. Now this orange line is where we are today in 2022, and you see that we have a lot of green. We've got some blue left. There's some big projects left, but there's hardly any yellow. Okay. So if we march forward towards the next decade, we need more yellow down here. That's why we need the new P5 plan, and that is really why we need you guys here at SNOMAS to tell us what are the new exciting scientific opportunities to fill out, okay? To perform the R&D so that we can build the experiments and do this science over the next decade. So this is the timeline. This is what Jim Segrist showed at his last HEP talk last spring. It's been arduous. There was a pause. Started really with the European strategy process, which finished up in 2020. Then you had the astrodecadal survey. You have SNOMAS, which is where we are now. You've got the Academy's EPP decadal survey, and then P5 starting out after that. It's a lot of moving parts. And you look at this and you say, haven't we kind of strategized to death? Each one of these actually serves its own role in the process and is very important. We're here at SNOMAS in July of 2022, and you know what that means? P5 hasn't started yet. So I'm not going to say a lot about the next P5 in my last couple of slides here. We'll talk more about that at the end of the meeting. The one thing I will say, because I think each and every one of you is going to come up to me during a coffee break and ask me this question, so I might as well just say it now. No, the panel members have not yet been selected. And yes, there is room for new projects. But I really want to conclude with the fact that we're here in SNOMAS now. And I'd like to echo a lot of what Steve said in his talk that started out this afternoon session. Oh, sorry. First, I had slides on every single thing. How much time do I have left? Are we getting late? Okay, I can do it in 5. I've got a highlight summary slide for each of these processes that preceded SNOMAS. So here's the European particle physics strategy was chaired by Helena Abramovitz. You can look at my slides on Indigo as well as anybody, as well as me standing here reading it to you. There's a lot of high priority future initiatives. They're focused on accelerators. An accelerator R&D was actually one of the first ones listed, is to ramp up the accelerator R&D for future technologies. That's incredibly important for the future of the energy frontier. Synergies with neighboring fields, nuclear physics, astroparticle. They also pointed out other essential scientific activities. There's a list of these, as well as environmental and society impact discussed. As Steve made the point that this is the responsibility of every one of us, and every working group here at SNOMAS should also be thinking about this. There's this international benchmarking panel. Particle physics is a global field. BSAC, the advisory panel for the Basic Energy Sciences program at the Department of Energy, had an international benchmarking panel. Took like a year to put this together. They're a slightly different field. They're a little more competitive than we are internationally. And so instead of being competitive in high energy physics, we want to take the stance of what makes the US a good global partner? What makes us a collaborator of choice, both for international researchers to come to the US and carry out their programs and their experiments, and realize I'm leaning down, and for US collaborators to go abroad and carry out the parts of our research program where the facilities are abroad. Bonnie and Patty are the two co-chairs, and they're going to be here and give a talk to you all. I believe it's next Sunday. The astrodecadal survey is very, very important for our field. There's a lot of connections between what they consider and what we consider. The report was released last fall. They went through a very similar process to us, where they collected of order 500 white papers and then tried to distill them into a set of recommendations. They're horrible at graphics. This is a charge for the next P5, is to do better than this. You think with astrophysics, they've got beautiful pictures, but they're horrible at graphics. But if you look at this pyramid of important programs and read through some of the different elements of this pyramid, you see the very, very strong connections with us. From new messengers and new physics, CMB stage 4 is on this pyramid, many different areas of overlap. And so their report is also an input to our planning process. The National Academy study, this has just been launched. We've heard about this earlier in the session. Jim talked about it. It's co-chaired by Maria and Michael. And they're also going to have a presentation on this. I think it's Sunday as well. And so I urge you to go to that and learn more about what they envision them to do. So back to SNOMAS. SNOMAS is absolutely a critical part of the US strategic planning. It has been since 1982. I neglected to take pictures of all the reports that are proceedings that line my bookshelves in my office before I left. So I was Googling last night, and it turns out that SNOMAS is so important, you can buy 3 of these proceedings online from Amazon. No joke. 1990, least desirable. It's only $8.45. It's only $8. B physics was $40, but the 1982 proceedings, now that's the gem at $40. So if you're missing that proceedings from your office bookshelves and you're hankering to get one, you know where to go. One thing that's impressive, actually, since we're talking about this, about the cover of the 1982 proceedings, it's a postage stamp here, but this is a list of names. Those are all the authors of papers in the proceedings. That was back when we can put the authors on the name of the proceedings on the cover. Okay, so what makes SNOMAS so important? There's a set of unique features of SNOMAS that is really just a highlight of our field and of SNOMAS itself. It's community driven. It's us, bottom up. It's what we want to do. That's not what anybody's telling us to do. It's science driven. It's what we want to do because we want to do the science, because it's pressing, it's urgent, exciting. Everyone can contribute. Everyone, anyone. I was a graduate student when I first went back in the dark ages, and loved it. Had a wonderful time. Worked with new people, worked in a new area. It was instrumental to me getting my job. So for you early career researchers out there, make the most of this. It's a full coverage of the field. It's perhaps the only time where we really get together and think about the field as a whole and how we unify and relate to each other. And we bring our different science communities together. Where else are you going to get underground facilities to talk to telescope people? It brings different generations of researchers together. The early career folks and the senior folks that have been around forever can sit down together and talk and meet each other. And it defines the key scientific questions and the approaches, not just a question, but the approaches. How are we going to answer these questions? How do we address them? And it's these results that guide the direction of our field and the next P5, but it's you guys, it's SNOMAS that really guides the direction of the field. And that is really given in the history of these reports, starting with 1982. Okay, so how do you SNOMAS? I put a registered trademark on there because I think Chris Quigg, sitting in the front row, has a trademark on that phrase. How to SNOMAS? These 10 days will be very busy. The Indigo schedule is so busy you can't even read it. I think I need magnifying glasses on top of my glasses in order to read it. It's finally here. There's been 2 years of Zoom meetings, at everybody's Zoom meetings and studies, a lot of work, a lot of presentations, a lot of discussion over Zoom within one focused area. The studies are mainly complete. Working group reports are preliminary drafts. Hundreds of white papers are written, talks have been given. What do you do now? Go outside your sphere. Steve said this. I'm just going to repeat it because it's so important. Go outside your sphere. You know your sphere. Whatever it is you did, whatever you contributed, you know that better than anybody else. But you don't know what somebody over there in another frontier has done, why that's important, why that's interesting. Go to meetings, learn something new, meet somebody new. You'll be colleagues with them for the rest of your lives. Attend meetings outside your own frontier. Nobody can go to everything, there's just way too much, but participate as much as you can. That's what you came here to do. Learn to appreciate the full breadth and wonder of our field. The breadth of the field really is fantastic in terms of all the different technologies, all the different things, all the science problems, and how they're really addressing the same basic questions. Discuss. Don't just sit there in talks all day, kind of like we did today, but discuss. Talk to people in coffee breaks, have discussion sessions during your parallel sessions. Don't just sit there in talks. And also be cognizant of the fact that only 2 of us that are registered are here in person. It's very hard, as we know, from sitting over Zoom over the last 2 years to really fully participate virtually. So, you know, folks raise their hand over Zoom and want to answer a question, involve them in the discussion too. So we're one community. We want to speak in one unified voice that represents all. Ever since I've been in science, there's been this analogy to we're wagons in a circle and we either shoot inwards at each other and we really want to shoot outwards. And I don't understand why we're shooting. I really don't. Okay. We've come a long ways, as I just said, each of us in our own individual frontier wagon. And here at SNOMAS, we've circled those wagons in a circle. The first image I pulled up had exactly the right number of wagons for each frontier and both of our agencies, NSF and DOE, because it takes all of us. So we're circled together. We're going to come out in the middle have our campfires, discuss, talk, look up at the stars in the sky, get inspired, and meet each other, and realize that we're one unified field trying to do something very impressive and dramatic and unique. So go out there and have fun. And let's not even think too much about P5, please. Let's just focus on doing snowmass right. Because if you do snowmass right, that's the best thing you can do for P5.
Okay, so why don't you sit at the table over there, and we'll have the other speakers join us. And we will proceed to something like a half an hour of Q&A. We'll do our best. Yes. So you're going to give the two mics.
Yeah.
To people in front. Okay. So we'll have somebody give you a mic when it's time to talk. And we're going to alternate questions between the Google Doc and in-person questions here. So I think we're starting with the Google Doc. Is that the plan?
Okay,
Okay.
we can start with the Google Doc. Again, I want to thank everyone for all their input. It's of course going to be impossible to address all of the questions live, and I'm going to try to synthesize some of them so that we can try to get through some of it, but we'll have to also go through and answer on the document as well. So maybe the largest number of questions on the Google Doc actually had to do with a theme that Steve raised beginning in his first talk, and that is the need for our field to address diversity, equity, and inclusion. And so I guess the question that I have for Joanne and Steve, and then for the agency representatives as well, is how can we at Snowmass do our job well to help you help us address diversity, equity, and inclusion? You have mics. Your mics are there.
Did you want Joanne to start?
Whoever, I guess let's have Joanne start and then we'll see what happens.
Okay, so diversity, equity, and inclusion is something near and dear to many of us. And it's been an issue for us for a long period of time. And really, only recently are we starting to recognize that, discuss it, and make serious attempts. Steve showed the pie chart at the beginning of his talk, and I don't think the pie chart would have been too different back a few years ago. Slight gains. So what can we do? Each one of us in our frontiers. There are some unique aspects to high energy physics in terms of the fact that we're such a global collaboration. We go elsewhere. Many of us go elsewhere internationally to do our work, to run our experiments. The theorists travel around to their meetings to discuss. How do we make the field more welcoming as a whole? It's a really good question.
So maybe if there's anyone
have a
else that
good
wants to
answer.
take a shot at addressing that, otherwise we can move on to the next question. We have a lot to go through.
Yeah, the other thing I would just say is one of the questions in the Google Doc, which by the way, thank you for all those very stimulating and important questions. I think there was a question, has there ever been any evidence that P5 report has addressed diversity, equity, and inclusion? And I took the sense of the question, if we do all this work, will it matter? Which is a good question. And I think the answer is yes. But let me try to explain an important point, which is P5, and I think it will be true here too, gets a charge. And it's told what to work on. And the results of P5 through HEP give advice to the agencies. but there's also giving advice to every university and institution that helps to create, negative environments. And the agencies have some programs or starting some programs. In case of NSF, have been there for a while. And those are the sorts of recommendations that could conceivably, I think, be made. The key thing is, what are the frontiers and what can SNOMAS provide in this direction? Recommendations in a report like this have to be well-motivated and actionable. They can't just be a statement of desire. They have to be clear and actionable. And there has to be somebody who's going to perform the action. Is it an agency thing? Is it hiring at universities? What is it who receives the recommendation of the action? And I think that's the kind of thing that can also be discussed here so that there can be real change. And of course, a lot of us are participating in both APS IDEA and in the Team Up report workshops and are keenly aware of those things as well for context. I hope that addresses the question. If not, please ask again.
I thought of something that actually answered the question instead of what I said before as well, in addition to what Steve said. Something that each frontier can do here is dedicate some discussion time to this topic, and then dedicate some space in your report to these actionable recommendations that Steve just discussed. Dedicate time to the topic and then include it in your report, and then that will be go forward and looked at.
The last thing I would say is, although P5 gets all this attention, why wait for P5? I think that it's something that ought to get into P5 report in some way, but it also can be strongly featured in the SNOMAS reports and in what we all come away from. And then it doesn't end after SNOMAS.
So I'd like to make one point, which is that this is a question in the Google Doc and that all of you are encouraged to respond to it and continue the discussion. That's one of the advantages of doing this. Now I'm going to try an experiment. I'm going to ask the audience if they have questions to raise their hand, and I'm going to watch how many of you try to click an icon on your laptop. You actually have a hand and you actually can raise it. So are there any questions from the in-person audience? Okay, there's one. That's good. So somebody will bring you a mic.
Great. Thank you all for very engaging talks. So this question is mostly for NSF and Jim Schenk. So I appreciated your discussion of the NSF initiatives and in particular the New Technology Directorate. And I wanted to solicit your thoughts about its relationship to fundamental science. As you said, it's not primarily a fundamental science project, but DOE has recently stood up the Accelerator R&D and Production Office, for example. And while it's in parallel, primarily technology, things like magnets, lasers, accelerators, all these things that we've heard talked about really have impact on fundamental R&D. So I just wanted to invite your comments on that, and of course, anyone else on the panel.
Yeah, thanks. So the new TIP directorate is still being formed, and we don't really know exactly how it's going to turn out, but clearly fundamental scientific research is part of it. We want that to turn into something that technology can take over. So it's connected. Exactly how, it's not clear yet. There are some fields that are clearly connected. I think it's clear we're going to do quantum information science is going to be tightly connected with TIP in the near future. That's kind of the vision of our NSF director also. He is into that kind of science, and so he wants to push it. And also the now AD, the assistant director of the new directorate, his background is in computing, and he is going to push quantum information also. So that's probably one of the first ones that's going to trigger the formation of the new TIP, but there will be more to follow.
Anyone
Uh,
else wish to? Well, you should ask.
Okay, so another question that was on the Google Doc had to do with the cap, if you will, or the cost that was quoted for LBNF doing the $3.13 billion. And both Dr. Kung and Dr. Merminga, you talked about that. Now we know we're in an environment where inflation is higher than that, and there's all sorts of other stresses. Are there particular strategies? I guess what's being asked in essence is, how strong is your commitment to maintain that cost?
I was hoping
A
Harriet would
negotiation.
start. As I said, LBNF in June is the highest priority of Fermilab. And I must say that back in March, when Harriet and Steve Binkley showed up at the Resource Review Board, that is a board of all the international partners for Dune, and they expressed their commitment to the project and the new funding profile that accelerated its completion by roughly 20 months is what made me accept my job. So this is a very important statement. I feel and I believe strongly that it is in the benefit of our entire field in the US to successfully complete this mega science project on time, according to which is actually very close to the original P5 specifications, projections. We can have the 120 megawatt kiloton years by 2037, which is in the 2035 timeframe. So it is for the credibility and of our field, both to ourselves, to the funding agencies, to the Congress, and to our international partners to complete this successfully. And so my commitment is unwavering. And also because, of course, the science is amazing, and we want to get there. Now, I can say that we're going to work together with DOE and scrub, as the committee told us, the budget and everything, and the project plan and the schedule. Any possibilities we identify for additional, let's say, in-kind contributions, and there may be those we're going to explore and exploit. If there are costs that are now on project that legitimately are operating costs, we're going to look into that. And I am committed to make every effort to support those. And then the last resort would be scope, but that already has been done. So I'm not sure whether the benefits of that are so great. But we're going to look at all this. And I want to just give you one example, recent example. LBNF Dune necessitates a new building at Fermilab for the production of targets and horns. It's called Target Systems Integration Building. It's on the order of $12 million. And we are working to reprogram other GPP funding in order to enable the construction of this building in a timely manner. So I'm already showing my commitment in practice, is what I'm saying.
Thank you. I especially applaud Leah's leadership, her commitment to explore options to hold to the projected cost of the project. I think what we also recognize is the very uncertain future that we're facing, from COVID to inflation to supply chain. So that's why I think we need to take a realistic view, while on one hand trying to do our best to anticipate these growth, but also put in place preparation in case there are unexpected growth. So I think what we need to do is continue to work together between DOE and the project and international teams. As Leah said, we have a few knobs to turn, but I think while our goal is to hold tight to that TPC, but we'll also need to be prepared to have some realistic barriers and really come up with contingency plan. That's what contingency is all about, to the known unknown and the unknown unknown, to be able to anticipate that and keep I think the overall goal that we want to deliver the project as soon as possible and in a successful manner is, I think that's the shared goal between us, the community, and Fermilab.
Okay, thank you. I think we'll move on. Are there questions from inside the room? There, I think Vladimir.
Vladimir Shiltsev, Fermilab. A question to Steve Ritz. From your presentation, it did sound like previous SNOMAS P5 combo was the best possible out of many previous, similar type of considerations and discussions. Given all that, is there anything you would suggest us to make things better? Was there something that would make difference compared to previous process that we can implement this time? Improvements, suggestions, something we shouldn't do, for example.
You mean based on last time? Yeah. I mean, that's going to be up to the whole new P5, whoever they are. If you're asking, did the last P5 have any problems because of what came out of SNOMAS last time? I think the answer is no. I think everything that was needed got there. And then, of course, that spawned the whole community interaction process as well during P5. It doesn't end when SNOMAS is over, right? There's a lot of community engagement. So I think everything, there were additional things in my talk about things we, in hindsight, might have done differently or said differently in P5 report. And I tried to highlight those in my talk as well. So I think if this SNOMAS can add to those pieces of information, that would probably benefit the next P5. I don't know if that answers your question. It's about the best I could do, though.
Okay, anyone else want to take a try at that, or should we move on? Sounds like we should move on.
Okay, there was a question in the Google Doc for Dr. Kung about the funding profile diagram, which was broken out by construction, operations, and research. And just trying to understand and ask you to expand maybe a little bit on your point that you showed that the increase in the funding was driven in many ways by the increase in construction. But I think your point was, and I'm asking you, that was because the case was made for that. And so the question is, how can we do a better job, or should we do a better job in making sure that that all facets of the program are strongly supported in the future? And there isn't some sense that, say, construction is happening at the expense of, which you said it wasn't, other parts of the program.
I think Joanne also commented on that from the HEP progress report. While there's really no guarantee that the funding going to project would have stayed in HEP, but at the same time, I think the program could have done a better job in space out the project in a way that the growth amongst the three components could be more balanced. I think that could be something the SNOMAS and especially the next P5 in terms of the phasing of the project could really help us in that sense. But at the same time, as I think I really firmly believe there, if you look at other programs in Office of Science, there has to be, for each of the component, really compelling vision in your research, in your facility operations, in your project, because these three often have very different stakeholders from the community, from the Hill, from the administration. And you need to have strong supporter for all three, but also make sure that the three really stitched together, integrated to form the overall program. And I also agree with Joanne that shooting from within is really not going to help us. But I think it's important that as you're doing your snowmass and then eventual P5 process, each of the Ps has to be standing alone to have that compelling vision, but then also keeping in mind, how do you stitch all three together? At least that's my view.
Are there any other responses? Joanne, did you want to expound on any more?
Something I've been thinking about in terms of how to attack an issue that is related to this in the next P5 report is how to estimate what a project is really going to cost and what the operations of that experiment is really going to cost. I think this is something, I mean, everybody does their best, right? I mean, here at Snowmass, everybody is calculating some experiment they want to do. They're doing their absolute best to come up with a cost. But when you actually sit down with the engineers and the project people, stuff keeps getting added. And something that we need to think about is how to more accurately feed in the cost of the things that P5 is going to consider. And I think that would go a long way in terms of balancing all the different programs and the different frontiers. If we actually had more accurate costs that were a little bit more believable.
I think that's a very important point. Scientists often we're too optimistic when we do cost estimation. And I think sometimes engaging independent outside sources to help bound or validate these cost estimates will go a long way.
And it's not, I just want to say, it's not on purpose, right? I mean, everybody is doing their absolute honest best. It's
Yes,
just when you
exactly.
sit in and fold everything in, it always goes up.
Yeah, of course, this was a big focus. And I think each time we do a little bit better, certainly the National Academies in their decadal survey of astronomy and astrophysics put a lot of effort into that. I would just say it's complicated because you also want projects at various stages of maturity. The more mature projects are going to look more expensive because more is known. I don't think we want to discourage newer ideas just because their costs aren't that well known yet. So it's very, I'm agreeing, but I'm saying there's also a level of inherent uncertainty that actually probably reflects something good.
Okay, so I think we'll take.
I would just add, it is one reason why the last P5 had, I think, recommendation 5, which said these were the priorities based on our understanding of the cost. And if they change significantly or the timescales change significantly, there should be developed some sort of process for reevaluation to try to accommodate that aspect.
Okay, so we'll take one more question, either from the room or the Google Doc. So, well, go ahead.
Okay, I guess Meenakshi.
Hi, this is Meenakshi Narayan from Brown University. I have a question for Joanne about the benchmarking panel. And would you clarify how this benchmarking panel would get community input? Because one of the charge is about understanding US leadership in key areas. And this is what we are also discussing right now at Snowmass, right? So it feels like there is going to be a Snowmass input, and then there is the sub-panel input. And what if they don't jive with each other? How do they work with each other? And all of this goes eventually to P5 or something, right? To define what to do.
No, that's a very good question. It's a very important point. And there are several ways. First of all, the benchmark panel has several different subcommittees, and they've already been quite active in terms of soliciting information from the community. Obviously, they haven't emailed everybody. But I think PIs at institutions have heard from them already. They're going to be here at Snowmass. They're giving a presentation, and we delayed the report. Originally, the charge said that the report was to be due July 1st, and we've delayed it now until the next HEP meeting, which will be end of October, precisely so that there can be input from the Snowmass reports into this panel.
You can
Yeah,
get it back.
Okay, I think they're literally just getting started, Mia.
Yeah, so
Yeah, they're
it would be
literally
nice
just
to
getting
have
started.
broader community input is what I would like to request.
Yeah,
Thank you.
yeah, yeah. They will get input.
Okay, so I think with that, we'll conclude today's session, except that we're going to invite Gordon back, who has some announcements. But I do want to say something. I suspect that this was one of the more tense days in your life. And I want to congratulate you on the performance of your team and turn it over to you.
Thank you. Thank you, Joel. And thank you, everybody who's here and was participating. That is obviously what makes this conference work. And frankly, from myself and the rest of the team's point of view is why we're doing this. Two very quick things. One is, please, when you get up, look around your chair, see if there's any trash that's been left over from earlier and just throw it in one of the bins on the way out. If we could leave this room clean, it would be absolutely awesome. The second thing is, tomorrow morning, we start at 8 o'clock, but we're distributed all across, not all across, but we're distributed in a couple of different buildings in campus. So most of them, no, all of them are within just a few minutes to, I think at most a 7 or 8 minute walk from here, but do look at your maps. Google Maps knows all these building names, so you should be able to just use your phone to navigate. And I think we'll see a lot of you tomorrow. Did you want to say something?
Just one quick thing. Can the Frontier conveners that are here please meet us briefly, very briefly, at the front of the room? But thank you all very much.